Drop it.
Hi guys, welcome back to another video. In this video, I'm going to demonstrate identity matrix. In linear algebra, identity matrix, also known as unit matrix, is where we have a square matrix, meaning the rows and columns are the same, and this time we have a value of 1 for the diagonal values and zeros everywhere. Let me show you an illustration. So we have on the screen two different types of identity matrix. We have a 2 by 2 and a 3 by 3 matrix. We could say that it's an identity matrix if the values that we input are zeros and 1. But we identify if it's an identity matrix if the diagonal value is 1 and 0 elsewhere. Same goes with this one. We have a 3 by 3 matrix. So the rows and columns must be the same. And then if you look at the values here, the diagonal values are all ones. So that sets or identifies it as an identity matrix. Let's show you our code here, our program, our output. So I have here the output of our program, in which case we're asked to enter an identity, an order of matrix. Let's say we have 3 by 3. Now let's type a regular set of numbers. So we have the input here, the elements, and then we'll be able to display it. But technically, based on our input, it's not an identity matrix. So as you can see, if you look at the diagonal values here, they are not number 1. Okay, let's run our program again. Let's have a 3 by 3 matrix. Let's have here 1, 0, 0, 0, 1, 0, 0, 0, 1. Enter. Now we have an identity matrix. If you look at the diagonal values, they're all ones, but the rest or elsewhere could be 0. We will be looking at the values here. Since we have here an equal 3 by 3 matrix, same with the previous example that we have, in order for us to get the identity matrix, we must compare row 1, column 1, row 2, column 2, row 3, column 3. All those values here must be set to 1. Okay? Let me explain to you the codes now for this program. Let me close this part. Okay. This section here is our variable declaration. We will be using the following variables: I and j for loop, n and m for our order of matrix, a for our array, and t will act as an indicator or a flag. By default, we set it to 0. Okay? Later, I'll explain to you further the purpose of this one. This section here allows to prompt the user to enter the order of matrix and inputs the value for n and m. This one here informs the user to enter n by m matrix. This is our input, okay, for us to accept n and m matrix. This section here displays the given matrix. Now let me explain to you the section where we identify whether it's a square matrix or not, and if it's an identity matrix. First thing that we have to look at is if that is a square matrix. We do that if the number of rows and columns are the same. So here we have a condition. If n is exactly equal to m, we check for it. If the value of n and m is equal, then it's a square matrix. But if it's not a square matrix. Okay? That's one of our rules. Okay. Next, we need to go over the loop here. We need to go over our array. So we must be able to identify whether if this value here if I and j is equal, then the value must be 1. Otherwise, if it's 0 or any other value, it's not an identity matrix. So we will go over the loop here. It will scan all our values. This will check for the diagonal value. This section here. It will check for the diagonal values. If the diagonal value is not equal to 1, what will happen is that we will change the value of t, which is our flag, to 1. So if it's 1 already, we will say that the matrix is not an identity matrix. For the other elements, is that we also check whether if it's not equal to 0, then we also change the value of t to 1, and that indicates it's also not an identity matrix. So if you see in our example earlier, first thing that we did is to check whether the order of matrix is the same. After that, we validate whether our input first is the diagonal values are all 1. If not, then it's not an identity matrix. And we also consider other areas to be equal to 0. Otherwise, it's also not an identity matrix. So here's another array implementation, an identity matrix. Hope you like the video. Thank you for watching. Bye.